Thank you, Dorit. First of all, I want to acknowledge the contribution of my partner in this project, Dr. Alon, and especially Professor Asya, and the R&D team of Chanita, especially Yakir and Alex, which are doing a great work. So as Dorit says, everything that you heard till now is probably something that were implanted in human. We are speaking one step behind, and this is a laboratory result, but I think that the results are so impressive that it is interesting to look at it. We know that PCO is still a problem, although people are saying that no. You can see the surveys, a survey from Belgium showed 46% of YA capsulotomy. If you heard Professor Menepace work, he is reporting that if you follow the patient long enough, you will see PCO with every kind of IOL. So PCO is still here. It's the main complication of cataract surgery. And today, with premium lenses, it's quite a problem. You want to give them perfect vision, and you can't have them back with you with decreased vision. We saw several lenses that showed fewer or less PCO, and this is the synchrony and the power vision, and we didn't understand why, and we thought that maybe these lenses are so bulky, opening the capsule, and this is the reason that we see less PCO. So with this idea, we went to an old idea. An old idea, it's not a new idea, of a ring that will open the capsule. The first one was Hara, that reported this, I think, in 91. And there are several new rings, Palikaris has one. And the idea, that if we'll have a ring that will open the capsule, maybe we will have less PCO. And we'll discuss soon why we think that opening the capsule will decrease the PCO rate. So Chanita designed a very complicated and nice ring. If you see, speaking about sharp edge, look at this sharp edge. This is a drawing. Later on, we'll see if it's similar in the real ring. So look at this sharp edge that we have here, and we have edge here, and here, very complicated ring to manufacture. And we design it with two materials, hydrophobic acrylic. One is hydrophobic and one is hydrophilic. So what are the stages when we are approaching a new device? First of all is to do an animal trial, to have a prototype and to implant it in a rabbit. And we did it. We implanted it in rabbits, and here you can see again the device. It was manufactured specifically for the rabbit with a larger diameter, 11 millimeter, with a height of 1.5 millimeter. And again, it was hydrophilic and hydrophobic acrylic. We implanted in this study two types of lenses with a similar design. One is the Chanita C-Lens AF, which is a hydrophilic lens, and the other one is Technis, which is a very similar design, but hydrophobic acrylic. And we had 6 groups. We implanted combination of the IOL and the ring, so we had 2 IOLs, hydrophobic and hydrophilic, and 2 lenses with the same, 2 rings with the same design, but one with manufactured from hydrophilic material and one with hydrophobic material. And we looked at the slit lamp, at the follow-up, 6 weeks of the PCO, and Miyake, Apple View, and the histology. What we found is that the implantation of the hydrophobic ring the hydrophilic ring was much easier than the hydrophobic. The hydrophobic, as you know, when you leave it for a long time in the cartridge, has the tendency to stick. You all know that when you implant hydrophobic lenses, you have to detach the haptics from the optic. And it was a problem when you have a ring like this. It was doable, but it was much easier with the hydrophilic lens. And it was not automatically to implant the lens into this tunnel of the ring. So it was something that required some manipulation. We saw visualization of the capsular bag, and this is because the ring was probably too big for the rabbit. But what we also could see that the capsule stayed open. So we achieved the goal of keeping the capsule open. And if we look at the PCO result, which is the main result of this study, you can see some example of control with a lot of PCO, and you know that rabbit after 6 weeks are full with PCO. And this is a regular, even good result of PCO in rabbit after 6 weeks. And look at the clear capsule that you can see with the same lens, but with the ring. Look at the result, and we accumulate it in numbers. So the control has 2.7 and 3.1, and the result of the hydrophobic and hydrophilic lenses were significantly lower for both rings and both IOLs, and both combinations. The next question is, how does it do it? Why we have less PCO? And there are two options. One is we have a blockage, that we have a square edge and we have a just blockage, another mechanical blockage of cells. And the other one is that we really reduce the proliferation of the cells. And the answer is coming from the Miyake view. When you look at the Miyake view, to the one that are not familiar with it, we are cutting the globes in the equator and looking from inside. So it's from inside outside. This is the ciliary processes, capsular bag, and looking from inside the eye outside, and look at the control. You can see a 360-degree Sommer's ring, which is the source for the PCO. And look at the rabbit with the ring and the IOL. You can see only scatter area of Sommer's rings. We also calculate the area of the Sommer's ring using the MetaLab software. And you can see that we marked the area of Sommer's rings, so we can calculate it. And you can see significant decrease of the Sommer's rings proliferation, 80% less Sommer's rings. So this is the answer how we do it. It's not only a blockage, a mechanical blockage, but the cells are not proliferating. And this is probably the mechanism of leaving the capsule open. No one knows how it's doing it. But maybe one of the things that if you leave the capsule open, the cell has maybe no ischemic process, and they are not starting to migrate and to proliferate. So you can see here when you do measurement of the area, you can see significant reduction of the Sommer's ring area. The next step, and then we still do not have all the result of the histology, but this is just preliminary and samples of the histology result. You can see a control eye. To the one that are not familiar with histology, this is the cornea, here is the iris, this is the sclera, and here we have the Sommer's ring. You can see a really significant Sommer's ring, and if you look closely at the capsule, here you can see this is the capsule, and you can see that there are some cells of the capsule. If you go to a higher magnification, you can see this is PCO. This is how we see PCO in the lab. So this is PCO. You can see cells on the capsule. If we go to another example, you can see here this is the iris, this is the pupil, cornea, and this is the capsule. And you can see that the capsule here you have in the center cells which are PCO. And here in magnification, this is the capsule, and this is the proliferation of cells, the balloon cells, as you're all familiar, which is the PCO. If we look at a non-stained preparat of the eyes, you can see this is the shadow of the lens, and you can see here the device, and I don't know if you can see that it's really exactly similar to what you saw in the drawing. I'll try to emphasize it, and you can see that you have this very sharp edge here at the point that I showed you earlier. And I don't know if you can see it here. You can see it here after staining. Here, if you can see it here, you have exactly the design that they planned, exactly with the sharp, very sharp edges, even sharper than you see here. This is the computer, you can do it really sharp. It's really sharp exactly in the way that Hanita designed it. You can see here the square capsule that the device pushed the capsule. You can see some cells here, but they are not growing into the capsule, and there are really less cells that you can see in the control. And if you look at the capsule, you can see this is a magnification of the capsule. It's really clear. There are no cells on the capsules. So in conclusion, we have a really encouraging result for prevention of PCO for both rings material. We found no difference between the hydrophobic and the hydrophilic ring, and the hydrophilic ring is much easier, so we think that this is the way to continue. Our results suggested that there is a primary PCO prevention. It's not secondary, it's not another blockage, it's not square edge. It's a primary PCO prevention. By leaving capsule open, the cells are not proliferating and not migrating into the visual axis. What are the next step? The next step, we went to cadaver eye and tried to adjust it to a human eye. So we tried to see if we can have one size fits all concept, which is much easier for all of us. And for doing it, we had 10 eyes of 5 donors, and we implanted several sizes of the ring from 8 to 9.5. And we implanted different IOLs, the C-lens AF, and this time we used the Acrisoft. First of all, what we did, we measured the eye, we measured the external length of the eye, we measured the capsule before we evacuated the lens and after we evacuated the lens, and we used the open sky technique. Open sky technique meaning that we are taking off the cornea, taking off the iris, and we can see what we are doing. And we measured the eyes, as I mentioned, the external length, and it was between 22.5 to 27.5. So you see, we have a variety of lenses, of IOL, of eyes sizes. The capsule was before evacuation of the lens, between 9.1 to 10.1 millimeter, and after evacuation between 9.3 to 11.3. So you can see we have a variety of capsule size. And here is an example how it looks in the human cadaver eye. You can see here the IOL, and you can see the ring, and you can see that it fits nicely inside the groove of the ring, and this is the Janita, and this is the Acrisoft lens. This is another view. This is the view that we have to thank Professor Asia for inventing it. This is what we call the keyhole view, and this is a view from the side. You can see we do a cut side, and you can see from the side how it nicely sits in the capsule, and this is just a nice demonstration. So what we found now, we found that a 9.5 millimeter fit nicely. All capsules are bag size, even the smaller one and the larger one. And what are the future steps? So we need to simplify the insertion of the IOL so it will go easier to the tunnel of the ring. So we have still some modification that we need to do, meaning that we are going now back to an animal trial to do the final design, and this next step will be a human trial, and I hope that next year we'll have probably some early result of the human trial. I want to thank everyone for their attention. And one more time, I want to thank the R&D staff of Janita. We can't do this without them, so I think you want a lot of acknowledgement, Yakir and Alex and Yuval. Thank you very much.